All right, here we are. We are back here in Cobra's headquarters in their wonderful crow's nest, which, is the golfer's heaven. But I'm here joined, Mike from Cobra Golf. How are you today? Thank you for joining me. We're going to dive into some kind of nerdy, cool stuff that you guys have been working on for, I think, longer than people know. But Cobra's been kind of synonymous with 3D printing for a long time now. But it goes back even farther than that. So what has, when we talk about 3D printing, I think everybody knows. They look at, they have a buddy who has their little 3D printer in their, home office or basement or garage, and they make little plastic parts. And that's used in golf. I mean, you guys
do that.
Yes, we do that stuff.
Yes.
But there's also actual clubs being made now, 3D print-wise. But with Cobra, how did 3D printing kind of come to be with Cobra? Because like I said, I mean, it's kind of one of those things when you say 3D printing, the first brand you think of is Cobra Golf. Because you guys have kind of promoted it and showed some of these products already. But how did 3D printing with Cobra kind of start?
Well, you hit the nail on the head when you said there's the polymer version of 3D printing.
Yep.
And we've been doing that for decades, as have most like product design sort of companies, where you print something, you look at it and you go, yeah, that shape's not quite right. And you tweak it and you print it again, you're like, oh, okay, I like that one a lot better. And then somebody looks at it and says, yeah, that's the one, right?
Yep.
And then you typically go to forging or casting with that in our business.
Yeah.
But with metal 3D printing, we actually had a conversation with a consortium of metal 3D printing entities, and they were providing powders, they're providing machines, providing expertise about 10 feet from here, like literally right behind us in that hit bay before it looked like this, about 11 years ago.
Wow.
Yeah. And we saw the potential. We had the same, you just said, wow. We said the same thing, like, wow, this is possible. And they were showing us how they could print titaniums and steels and the quality of the print. And we looked at the whole thing and said, man, we're going to be able to prototype with this real soon. But there's no way in heck we're going to be able to sell it.
Yeah.
Because it's going to be really expensive. I mean, back then, if we wanted to print an iron head, it might have been $500 to $1,000.
Wow. For just one. I mean, just one.
For one, yes. And then you put a shaft in that and mark it up and then mark it again for retail. And now you're looking at, it could be a $20,000 set of irons.
Yeah.
Or more, depending upon the tech we put into it. But we knew there was a huge possibility with that technology. We knew we could prototype with it. We knew we'd be able to make working clubs from it.
Yeah.
We just didn't know when we'd be able to commercialize it. And fast forward about 3 or 4 years from there, which is now, let's say 5 or 6 years ago, we started printing metal components for tour players.
Okay.
So Ricky, Bryson, Lexi, any of the tour players we had, we were making things and 3D printing them, and we're doing it faster than you could tool it up to forge it, or faster than you could tool it up to cast it. We could print stuff in weeks as opposed to waiting months to get cast or forged parts.
Yeah.
And so the time advantage there was just massive, but the head still cost a lot. Right? So now let's say you're talking a $10,000 set of irons. So it was not in the realm of being able to commercialize it.
Yep.
Well, just like that TV used to cost $15,000, now you can get that one at Costco for maybe $1,200, whatever it is.
Maybe less.
Maybe less. Yeah, with way more features. The same thing happened with metal 3D printing. The cost of producing the material, and the material is remarkable.
Yeah.
It's as fine as powdered sugar. I mean, it's super fine. If you touch me, you're like, what is this? Almost like cigarette ash, right? It's very, very fine, but it's metal. In our case, it's stainless steel. The machine required to print it is an expensive machine.
Oh, I bet.
Yeah. I mean, at the time, those machines were, let's say, $2 or $3 million a piece.
Oh, wow.
Now, something comparable is down to like maybe $300,000.
So it's still a lot of money, but
it's a lot of money.
Like you said.
It's a huge investment. So over time, as the price of a lot of technologies come down, so has the cost of 3D printing metal.
Yep.
To the point where now we've been able to commercialize a set of limited irons, and then we're going to roll this out now as the 3DP Tour. Very similar construction, slightly different branding, but it's going to be in line.
Yeah.
And people would say, why, right? And it feels like climbing the mountain, because we can, damn it. Right? And we know that makes a hell of an iron.
Yeah. Well, that's the other thing interesting, too, is when you mentioned, we're all familiar with forge, we're familiar with casting, and those are the two things that most golf clubs have been made out of forever. I mean, It seems like when you look at a set of irons or even drivers, you've got cast, forge, whatever. 3D printing is a new way, but what are, I mean, I know there's a lot of advantages, but what are kind of the big advantage of 3D printing metal instead of just casting it or forging it like a traditional iron's been done for, a long time?
And I'm not here to bash on forging or casting
Yeah.
because those aren't going to go away. And
you still have irons that we do that.
Oh, yeah.
And there's still Cobra irons that are both. So.
Yes. And you can make great clubs from that.
Yep.
But you can do things with 3D printing you can't do with either one of those two. You can make a hollow iron by either forging it or casting it and then welding or otherwise attaching other components to it.
Yep.
Then you typically have to fill that with a foam so that it sounds good because you don't have a metallic structure, part of the original build, as we call it, the parent metal, that is encapsulated and attached to everything on the inside. And with our 3DP Tour iron, there is a lattice on the inside that is integral to the print, which means it's attached to the face, it's attached to the back, it's attached to the sides. And it represents only about 11% of the density of if it were solid steel.
Okay.
So you've saved a boatload, as I say, not a technical term, 100 grams of mass you've saved.
Wow, that's a
right?
lot. I mean, that's half a head almost. I mean, depending on where it falls in the line, that's almost 50%.
But the beauty of what I said with the lattice touching everything on the inside, now it still behaves as if it's a solid piece of steel because it provides an adequate amount of stiffness and strength so that it feels like a forged blade.
Yeah.
But now there's 100 grams missing. Where are you going to put that? We put it in tungsten, wide and low, so now you've dropped the center of gravity, you've increased the moment of inertia, so you've made this iron that looks like a blade, it feels like a blade, and then you hit a couple of shots, you go, man, that's really good. Okay, now miss one. Miss one on the toe or in the heel or low or high or whatever, and you see remarkable performance. You don't lose nearly as much distance as you would with a forged blade with a much lower moment of inertia.
Yeah, and that inside lattice structure, I mean, there's a lot you can do with casting. We've seen some pretty amazing designs over the years in terms of iron shaping and cavities and things like that.
Mm-hmm.
And with casting, you get a lot of possibilities, but a lattice structure is impossible to do with casting or forging or anything like that, correct?
You just can't do it. Yeah, this is right now, right? Because we're all in the innovation business. As of today, that's the only way you could produce this club.
Yep.
Yeah.
And when you build that lattice structure, I mean, not only, like you said, I mean, it's internally there, but it is supporting the face, it's supporting the structure of the iron, but it's also something where, like you mentioned, multiple pieces, there's no way to weld. If you put two pieces together, there's no way to weld that lattice to the front or the back or anything like that. It can only be done this way.
Yeah, you're not going to weld it, you're not going to glue it, right? You could get that structure in there, but it's just not going to behave as if it were, as I call it, parent metal or the same alloy, same metal, all the way through. So that lattice is created, built, printed at the same time as the rest of the structure.
Yeah.
That's why it's an integral part of it.
Yep. And so we saw last year, we had a limited run, a small run of an iron that was 3D printed that was sold to consumers kind of for the first time ever. I mean, I don't think a 3D printed set of irons had been sold previously.
I don't believe so, not to our knowledge. Yeah. They've been played, but not sold.
Yep.
Yeah.
So we had a set of irons last year that came out, and now instead of a limited run, we're going to give kind of everybody the chance to kind of feel and experience a 3D printed iron with the brand new 3DP Tour. Now, like you mentioned, the interesting thing is I think, especially a lot of Golf WRX members are players who are very aspiring, or they at one time were a very good competitive player, and now family, work life, all the stuff that comes with growing up happens, and they're that player who maybe played blades or a forged CB or something like that, and they love that look. They love that profile, that small, compact look. They love what those things did, but the game just isn't quite there anymore. They just don't have the time to work on it. And when you looked at last year's limited, it was a very small, compact iron, but as you mentioned, played much bigger. With this new iron, we're kind of giving everybody that same ability, right? We've got a small, compact head, really good looking, but we're getting the forgiveness, the playability of a much larger iron in the lineup.
Yes. Yeah.
So
it's way too good to not run it up again. It just was. Yeah.
So when you're looking at that, I mean, because that I think is a little bit of the tough part too, of deciding where do you go with an iron? Do you make it something like that? Do you make it something a little bit bigger and kind of crazy and all that? How did you kind of settle on, let's keep it small, let's keep it this look, and release the mass? How was that the kind of decision, or what was that kind of like to make this iron instead of something else larger or something kind of directed more at the more forgiving side of golf?
So you really eloquently stated half of the equation, which was that guy or gal that's been playing like a blade iron, could be an MB, a CB, even like a forged tour sort of iron, right? But like, man, I need a little help, just a little help getting that ball in the air. I need a little bit more forgiveness, right? And then on the other side of that spectrum, I would say the player who's been playing, say like a forged tech, right? It's like, I like the distance I'm getting, but I sure would like a little bit better feel, a little more compact look. I don't want to give up forgiveness. And I don't want to ever hit a flyer. I mean, I want my 173 yard 6-iron to always go 173. Okay, 171 to 175, right? But I want that consistency. And that's what a solid club does for you. So now you've got both ends of that. You bookend it. Right in the middle is this iron that can be played by someone who is really accomplished but needs a little help, or has had the help they've wanted. They're ready to graduate. They're ready to go from a 101 class to a 201. And actually, this might be a 501 course. Yeah, this might be an advanced course. But it's both ends, right? And that's what we said. This has the greatest chance to make the biggest difference for players who can discern it quickly. And that's what we did. Those players, both ends of that spectrum, within a few shots go, whoa, what is this?
And I did the same thing. And it was funny because you and I were on a phone call previously and said, oh, have you hit the limited? And I said, I have a 7-iron. I hadn't hit it. I hadn't gotten around to hitting it. And I finally did. And it was really, and I didn't know what to kind of expect at the time. Like it was there. It was really good looking. But it was just kind of like, okay, well, let's just see. And I mean, it was amazing how even struggling to stay in that single digit handicap some days could go out and hit that iron and find a lot of success with it. But like you mentioned, the sound and feel was not what I expected. I think hitting, the whole market has shifted towards hollow body irons. That's been a huge thing. And some are filled, some are not, just depends on the design. This is a hollow body iron that doesn't feel like a hollow body iron. And I think we've all been conditioned that says, well, if you want like a forged feel, you have to have that one piece CB or MB, or it can't have multiple pieces hanging around or whatever. But this is a completely hollow body. And I wouldn't say completely hollow, but it's got a lattice.
Almost.
But it's got a lot of air inside.
It does.
A lot of space.
Oh, yeah.
And it doesn't have any weird ringing or tinging or any type of weird sound to it. And is that inherent just through the lattice structure, or is that something that you guys had to kind of engineer into the head?
A little of both, but mostly the lattice. I'd give the lattice the credit.
Wow.
So it's like hollow body construction, kind of, wink, wink, nudge, nudge, because the lattice does represent about 11% of the total mass if it were solid steel. So it's not insignificant, but it's significantly lighter. Okay? So it's like hollow body construction, but with solid body physics. That's the kicker. Okay? The physics of this thing is more like a solid body. And when I say solid body, I'm talking like a forged iron, where the face is, thick enough such that it's not going to act like an unsupported face and give you some spring effect and give you some ball speed, right? So it's thick, okay? That type of construction has a much higher, I'm going to get nerdy for a second, nerd alert.
I love it.
A higher frequency when you hit it. And so high and so highly damp that the sound you're hearing is probably primarily golf ball.
Oh wow!
With the blade iron, like that really solid feel, like that's mostly golf ball. And this iron behaves that way because that lattice, where sure it's mostly air, it provides enough stiffness for the impact physics of a golf ball on a face at say 90, 100 miles an hour even. It's still going to behave like a solid club. That's the ticket. So like I said, kind of hollow body construction with solid body physics.
So if you're looking for an iron that has that thin base for a lot of distance on it, this isn't it. Even though it's hollow body, and we've been again conditioned that hollow body irons are typically distance oriented irons. Even on the player side, they still have a little heat. The faces are thin. This face isn't going to do that. It's not meant to produce a ton of ball speed or produce these amazing distance numbers. It's really made as a little bit more of a precision tool for those players who want consistency throughout the set.
Now I will say, right, you're right, it's not going to have those jumpers. It's not going to have a ball speed related flyer. Right? Nor a spin related flyer. Okay? And for the players who think that's really cool, at some point they're like, wait a minute, I normally hit my 7-iron, 156 yards, and
Yep.
I nutted one, and it went 168, and I'm dead. I made triple.
Yeah.
At some point, those players go, this ain't cute anymore. It's just not, right?
Yep.
And that's when they could graduate from that end of the spectrum down towards something that's a little more consistent. But I will say, with that tungsten and getting the CG really low, people are also shocked for its loft, how much distance they get out of it. The
Yeah.
center of gravity is so low, they're getting more ball speed out of that than they would with a typical forged iron. Center of gravity is higher. It's higher than the typical ball impact location. So it's not like you're losing speed with an MB, but you're gaining speed with this one.
Yeah.
I'd say it that way. And you're also reducing spin a little and raising launch angle. And here's another serendipitous, nerd alert. We have found that when you increase the moment of inertia in an iron, there's a serendipitous effect where the launch angle goes up a little bit more than we would have expected.
Really?
Yes, we found that with F9, actually, years ago. I remember when I first hit that thing, it was just a beast. And this is very similar. It's a beast. You get that, like I said, I'm going to say it again, mass down, low, and out.
Yep.
Good things happen in speed, spin, and launch angle.
No.
Yeah.
So this one here, I mean, the whole center section's a lattice, and then it has kind of two pockets.
Yeah.
Where you guys have shoved a ton of tungsten into.
Technically a ton.
Again, another ton.
Okay,
I mean,
100 grams.
Not quite 2,000 pounds, but yeah, I mean, and then basically capped it off. And then, I mean, we've seen 3D printed stuff before as well, and it comes out, it's got a little roughness to it. I mean, it looks fairly that shape. But then you've taken it even further with that again, and now it's not hand polished. It's not people sitting there. It's all robotic polished now.
We do a lot of robotic polishing. Yes.
In order to make sure extreme consistency again, you've got a robot that goes through and finishes off, polishes it, and then you come out with what you see here.
Mm-hmm.
But how does that? I mean, that's got to be an interesting thing in itself because yes, you're getting the consistency, but it has to take a lot to get there. I mean, I know we had robots for a long time, but that had to be a kind of a heavy lift of its own to be able to take the raw product from here, which you did show me at one point, and it's pretty rough.
It's rough, yeah.
And to get that into the final playing shape, it still had to take a little bit of kind of work there to get that process down.
Yeah, we work very closely with the vendor. It's funny, we'll go back nerd alert, back one step, just to print that thing. So it gets printed in a toe down, hosel kind of in this orientation, and it's 2,600 layers.
From start to finish.
From nothing to it's done, okay? And getting the lattice built correctly on the inside so that the lattice, because you're looking at it, you can't build a lattice like this, okay? It'll collapse. You have to build it at least at 45 degrees. So you've got to figure out, okay, how do I build this so it doesn't need any support structure in the inside?
Yeah.
And if people, 3D printing now, as you said, is pretty ubiquitous, so you see it all over the place. You'll see 3D printing machines where there's a structure that's holding up the actual part.
Yeah.
And the structure's built at the same time. Then when it's done, you snap that structure off or sand it or whatever, and there's your part. We can't do that because the lattice is on the inside. You can't get to any support structure.
It's done.
So on top of figuring out how to polish it, also figuring out how you're going to build it such that when it comes out, you can pour the powder out of it, and the lattice is structurally, it has structural integrity.
Yeah.
Right? So that was a big deal. So there was a whole bunch of manufacturing things that had to be done to make this.
Yep.
Yeah.
And you mentioned, I mean, it wasn't like you just decided, hey, we're going to make a lattice and boom, it was done.
No.
There were a few kind of versions of it to try to figure out, like you said, how to make sure it doesn't collapse during making it. How does it work the way we need it to?
So durable. Got to sound good.
Yeah.
Oh yeah.
So that was even in itself. I mean, and it's a pretty interesting structure when you see it. I mean, there's a lot going on in there.
Yeah.
And to make sure that works. Yeah. I mean, this is a set of irons that I got to say that I would have to think took far more development than just a regular player's iron that would be usually that size.
A regular player's iron is going to be solid.
Yeah.
I mean, literally, it's going to be solid.
And done.
And so the biggest deal with that is, okay, if we're going to change the industrial design, the look, right?
Yep.
Move the name around, change some of the lines, right? Then you get in all sorts of interesting conversations on the industrial design of that head, okay? And that takes a while to get that design locked in. In this case, we had to engineer it. We had to develop it, right? Had to design it because it needs to look pretty also.
Yeah.
So there was a lot that went into that. Yeah.
And it's pretty cool to see, like we said, I mean, to be able to have an iron like this that performs so much bigger than it really is. I mean, you would think that the forgiveness, the consistency, all that, it would basically be a bigger iron if it was done traditionally traditionally cast or forged. And now to think, what are the possibilities after this? If you do make it bigger and you go, but the possibilities are pretty exciting.
Yeah.
Back in the R&D room, when you can kind of start thinking of, well, we did all this in this size. If we go to this size, whoa, like what these things could really. So it must open up a lot of possibilities for your team to kind of go, we can do some cool stuff here coming down the line.
You see me twitching over here?
That's right.
Yeah. Smaller.
Yeah.
Right? Or just different. Right? There are so many possibilities that we can do with this, and you've nailed many of them. If we go any farther, I'm going to have you sign an NDA. Right?
We're going to be able to publish this.
Yep. You're going to have to be an employee.
Yep. But I mean, and not even irons. I got to think that you could probably look at wedge. I mean, any club in the bag, and almost say there's probably some part of this that you can incorporate to just keep enhancing performance of pretty much every club in the bag. I mean, maybe not drivers. I don't know if they necessarily need a lattice structure inside of them, but I think for a lot of clubs in the bag that you typically don't associate with technology, this could make a big difference in performance, as this technology keeps evolving.
Oh, yeah. Yeah, with all of those, you might be surprised on the driver thing someday. Well, we've already done wedges, right?
Yep.
For Ricky and for Gary and for Duffner.
Yep.
Ricky had a grind he really, really liked, and Ben could keep grinding them, or Mike McDonald, one of my development engineers in the innovation group, said, let's scan that thing, right? And then he gives it to Ryan Roach and Drew Whited, and they figure out exactly how we're going to make this thing, and they print it, and it looks just like Ricky's wedge. And Ricky hits it once, and he goes, "Yep, that's it."
Yep.
Yeah.
And
because, it was awesome.
So we have the 3DP tour. It'll be available pretty much everywhere for the most part. I mean, I don't think it'll be
not quite everywhere.
Yeah,
but you will be able to find it.
Yes.
Okay.
You'll be able to get it, and there's not just 500 sets of them. There's going to be more than that. But this iron here, I mean, kind of, I think we talked about it a little bit, but I mean, for the person who's looking at this saying, is it for me, is it not? I mean, I think we kind of said it, that person who, maybe you're not the highest of handicaps, but you're somebody, it's going to fit a wide range of players. Like we've already seen the old version on tour, the limited one, right? It already has a win on tour.
Yes.
So we've seen that level of competitor.
Angel Hidalgo.
And we're going to see, through the whole handicap range, a lot of players be able to play this iron, which is pretty cool.
By the time this gets aired, there will be more players playing it. I can almost guarantee it. Yeah. Oh yeah. This or something like it.
Yeah.
Yeah.
And it's pretty cool. I mean, it's literally 3D printed stainless steel with tungsten. I think if you would have probably, like you said years ago, said this is how upset irons was going to be made, you would have probably laughed at that person's face and said, "Yeah, right."
You might have. Yeah.
I mean, 3D printing metal, it doesn't make sense.
No.
But
no. And it's weird. So a few comments on that, right? So we get nerdy again.
Yeah.
I've heard some people go, wait a minute, it can't feel good and it's got to be fragile, right? It's 3D printed. Well, the strength of that material when printed is closer to forging than it is casting. I'll exaggerate. Let's say here's the strength of casting, here's the strength of forging. Yeah. Right? 3D printing's closer to forging than it is casting.
Wow.
Which was shocking to us too, right? The more we learned about, like, my gosh, of course we can make clubs out of this. Yeah. It's strong material. Yeah.
And that's, I mean, nowadays, not even in irons, you can print a bunch of different metals. It's not even just stainless steel. You can do a ton of different things. So, again,
almost any metal can be 3D printed. Almost.
Which is pretty wild. So, yeah, these are exciting. I can't wait for these to come out. I definitely, after you told me I had to hit the limited one, and I'm glad you did, because I probably would have kind of just set the 7-iron aside and not done it. But to see that, the performance you can have while not giving up the feel, the look, all that is pretty exciting. And like I said, for a guy like me who is that, I want that cheater club. I want that club that makes me feel good, but it helps me. And having that ability in something like this, in this package, is pretty special.
That's cool. Don't sell yourself short, by the way. I will also say, just throwing one more out there, we've had a few players that would typically fit, let's say they're about a 20 handicap, and they would fit into like a dark speed iron really well.
Yeah.
We've had a few of our fitters say, just try this. Just hit it. Just to see. I'm just curious, right? They hit it better.
Yeah.
And I don't know if it was confidence. The fitter thought it might have been turf interaction, right? The CG location is much lower.
Yep.
So all of that combined, they hit it really, really well, which was a head scratcher for them, right? Because now it's like, I don't necessarily have to play a bigger Game Improved iron. I could play this. I could go like right to that iron.
Yeah.
So I encourage anyone who's even thinking about it to go out there and just
True.
try it. Just hit it.
Yeah.
Yeah.
At minimum, you're not going to be disappointed with the sound and feel. At
No.
absolute minimum.
That much I'll
So,
guarantee.
yeah.
Oh, yeah.
And you're going to be shocked when you hit that first one off the toe and it goes straighter and further than you expected.
Yeah.
You're going to be pretty shocked because I know that's what happened to me.
Mhm.
So, yeah, brand new 3DP Tour irons. Mike, thank you so much for breaking these down.
My pleasure.
Awesome. Can't
Yeah.
wait to get out and hit these when they come out, which by the time we publish this, they will be.
Got it.
But can't be wait to go hit these. And thanks
Cool.
for all the knowledge and all the nerdiness.
My pleasure. Thank you.